All right, so we're ready to start talking about the flow of electrons. So we've got this light bulb and the battery, and we're going to connect it, okay? And once it's connected, we've got a circuit here, and we've got this higher potential at the positive terminal. Okay, we've got higher potential there. So that means the electrons inside this light bulb are going to start to move towards that higher potential. Okay? Now, when we draw this, we've got this picture right here. It looks the way it would in real life. Okay, you've got some wires, you've got the light bulb, you've got the battery. But when we draw this, okay, we're going to use some diagrams and some shorthand. So we would draw the battery like so. We've got our positive terminal and our negative terminal. Okay, and this little symbol is for a battery. Now, also when we draw these, we draw everything at 90-degree angles. So we make all the turns at 90-degree angles. So we don't have any curved wires like up there. And a light bulb is going to be a circle with a little like curlicue type thing inside of it. Okay, so this is what a light bulb looks like. The symbol for a light bulb, the symbol for a battery, and then these are the wires, and we draw them always at 90-degree angles when we need to make a turn. All right, so what happens is, again, the little electrons in this light bulb, when they get connected, start moving towards the positive terminal, the higher potential. Okay, now what does that mean? Right here in this wire. Well, in this wire, an electron is significantly smaller than the width of your wire. So you've got a lot of electrons in here. We're going to just draw one of them. Okay? And when it starts moving, it doesn't move in a nice straight line. What's actually happening is it's drifting and flowing around in here, and it might even double back and then come forward, okay, and up and down, and it's kind of turbulent in there, okay? It moves all around. But overall, it's moving this towards the positive, okay, terminal, or towards the higher potential, okay? It's drifting that way, okay? And we refer to the movement of the electrons as the electric current. Kind of like in the river, you've got the current of the river. It's got all the little particles of the water, okay? So there's a lot of little electrons similarly here, okay? And in the water of the river, they don't all move in a nice straight line. They run into things, they move backwards and forwards, but they go mostly in that direction. They drift in that positive direction, okay? And the current is the value that tells us how fast they're moving, okay? So let's look at some things. Current. Electric current is the flow of electrons, or how fast the electrons are moving. Drift velocity, again, because it's not moving in a nice straight line. It's the net velocity of a charge carrier moving in an electric field. The symbol for current is the letter I. The units are coulombs per second, or an amp. Okay? And the equation, current is the amount of charge that passes per second. It's a rate of change. Now, we're going to talk about conventional current versus the motion of electrons. Well, conventional current, when current was starting to be talked about, Benjamin Franklin was looking at it, and he was trying to figure out how things were moving, and so he didn't know whether it was the positive charge or the negative charge that was moving. So he hypothesized that the positive charge was moving. Okay, so he said the positive charge is moving, okay, and so the positive charge went toward the lower potential, okay. Unfortunately, he was incorrect, okay, and while some books still talk about current conventionally, and they've got the positive moving toward the lower potential, and that's fine as long as you're consistent, okay. Some other books have started going to the motion of the actual motion of the electrons, and what we just looked at here is that the electrons, okay, or the negative charge is the one that's moving. And so that means the negative charge goes towards the higher potential. The last thing we want to look at here are the two types of current. AC, well, AC stands for the alternating current. And DC stands for direct current. DC is what we have in batteries, okay? Why? Because the positive and the negative terminals stay positive and negative always. They don't change. So this is the positive terminal, it stays positive. This is the negative terminal, it stays negative. You've got your electron in here, so it is going to drift towards the positive terminal, towards the higher potential the entire time, okay? AC is different, okay? AC is what we've got in our outlets, okay? And AC current alternates. Why does it alternate? Well, maybe we start off with this being the higher potential and that's the lower potential, and you've got your electron in here, and so it's drifting towards the higher, and then we switch it. We make this end the negative terminal and this end the positive terminal, and now the electron is going to again drift towards higher potential, so it's going to start moving this direction. And then we switch it back, so it's going the other direction, and then back and forth, back and forth, back and forth. And in the United States, it goes back and forth 60 times per second. So this little electron is going to start drifting each way 60 times per second.